So in the previous session, we had a discussion about polymorphism in Java. So polymorphism, it's a feature of object-oriented programming where you can achieve polymorphism in Java in two ways. Either you can go with the compile time polymorphism, and you can go with the runtime polymorphism. So in compile time polymorphism, we'll implement it with the help of method overloading, and we discussed about the restriction while we are going for method overloading. Then we moved on to how to implement runtime polymorphism. So for implementing runtime polymorphism, we have two approaches. Either you can go with overriding, or you can go with the SuperClass reference variable, right? So yesterday we discussed about overriding. So in overriding we discussed about certain restriction of overriding a method in Java. So method name should be same, and return type should be same, argument should be same, and more importantly, you have to decide what kind of access modifier we are going to use in overriding, right? So today we'll discuss about the SuperClass reference. So SuperClass reference in method overriding. So what is a SuperClass reference? So in SuperClass reference, SuperClass, which means that the parent class, right? So SuperClass can refer, SuperClass reference can hold child objects. So this is the idea you should remember, right? So whenever you try to create a reference for the superclass, that reference can able to refer child class objects, right? So we'll see what it means that. So I'm going to have a separate class so that you can understand it better. So I'm going to create a class figure to represent mathematical shapes. So I'm going to have a figure class with the two attributes. So I can go with public int dimension, so dimension 1, and I can go with another dimension 2. So I have 2 dimension for the figure class, and I'm going to have a method for calculating an area. So find area. So I have my own method to calculate the area. So inside this figure class, we don't know how many dimensions are there in a particular figure. So in that case, you cannot define your own logic inside your figure class. So here I'm going to have a template inside that. So I'm going to simply print this is inside a figure class area, right? So this is for figure class area. Now I'm going to create a subclass. It is of rectangle. So inside rectangle, I'm going to inherit all the properties of figure class. So I'm going to extend figure. So which means that figure is a parent class for the rectangle class. So inside the rectangle, the 2 public properties will be inherited. Apart from that, the method also getting inherited. So here I'm going to apply overriding. So I'm going to have a same method. And with a different implementation. So in case of overriding, we have to remember that the return type should be same, and the method name should be same, and the argument should be same. And we discussed about what are all the access modifiers you can use it during overriding also, right? So inside this rectangle, I'm going to calculate the area of the rectangle. So here I'm going to simply calculate the area, that is dimension 1 into dimension 2, right? So that returns the area of the rectangle, right? So the dimension 1 and dimension 2, that comes from your parent class, right? So that is about the class we have created. So we have created 2 classes, figure and rectangle. Now we will go with another now I'm going to have a test class to test the methods of the figure and rectangle. So test reference. So that is a class I have created. Here I'm going to keep my main method, and inside that, so as you all know how to create object for both the classes, right? Now I'm going to show how to create an object for the rectangle class. So in case of rectangle class, so we have created it, right? So we have created rectangle. Now we'll invoke the area method. So I'm going to invoke area method. So here in our given class we have two find area method. One method is a part of figure class and another method is a part of find a rectangle class. So here we will see which method is being executed. So here we are getting 0 as a result. So here the object type of R, so the type of R is a rectangle. So here this reference dot find area will invoke the find area method, which is a part of rectangle class. So inside the rectangle class we have find area method. So we are trying to calculate the area of the rectangle. So here we are printing the dimension 1 and dimension 2. So it is getting 0. Why? Because the dimension 1 dimension 2 which we have declared inside the figure class are known as instance variable. So the instance variable will always have a default values, and for the type integer the default value is 0. So here 0 is getting printed. Now we will see how to create a reference for the superclass, right? So that is the idea behind runtime polymorphism. So superclass reference. So for creating superclass reference, you simply declare it. So for example, here the superclass is a figure. I am going to declare it as figure F. So here F is known as a superclass reference. And in Java, the superclass reference either can refer the object of the superclass as well as the object of the child class. So here I'm going with referring object of the parent class. So F equal to new figure of. So now we'll try to run the code. So I have to save it first. So here we have created an object, the object that is being referred in F. So here the superclass reference F is pointing out the parent class reference, right, or the same class reference. So now F dot find area, we will see what is the output. So here now the figure area, the find area, which is part of the figure class, is being executed. Why? Because the type of this object reference is figure. So that invokes the method which is part of your figure class. So this is one way. So here the superclass is referring the same object reference. Apart from that, in Java, superclass reference can refer child class. So can refer child class object. So we will see how to do that. So we have already created a reference F. So I'm going to put it in different way. So F equal to new. So equal to new rectangle of, right? So now what we have done here is we are creating an object for the child class and we are assigning it to the superclass reference. So this is a valid approach in Java. So superclass can always refer the objects of its child, right? Now we will try to invoke the find area method and we'll look at the output. So now if you look at the output, you are invoking the find area method, but internally it invokes the find area implementation from its child class. Why? Because in superclass reference you are holding the object of rectangle, right? So internally this will invoke a find area method which is part of the rectangle class alone. So superclass reference can refer the child class object which is legal, right? So with the help of that you can achieve runtime polymorphism, right? So why I'm saying this here is in So the object creation, right? So here we are trying to create an object for the child, and we are assigning it to the superclass reference, right? So the compiler doesn't know that whether the superclass reference is pointing out which object. So the object is created at the runtime. So at the runtime only your JVM or your interpreter will decide which find area method is to be executed, whether the find area method which is part of rectangle, or the find area method which is part of figure class. So that decision will be taken at the runtime. So we call it as runtime polymorphism. So with the help of superclass reference also you can achieve runtime polymorphism. But in Java you should not do one thing. Child class reference cannot refer superclass. So you cannot do that in the reverse way. So for example, I'm going to create a reference for the child. So a rectangle. So rectangle R1. So I have declared a reference for the child. Now I'm going to create it in a different way. New figure of, right? So here what I have done here is I am creating the reference for the I have created an object for the parent and I am assigning it to the child. So this is not allowed in Java. If you do that you will get compile time error. So in Java you can either superclass reference can hold the child class object, but child class can never hold the parent class object. So this is what you should remember regarding superclass reference in Java, right? So apart from that, the runtime polymorphism can be referred in a different way, that is dynamic method dispatch. So this is a different terminology to represent dynamic runtime polymorphism. So both are same. In runtime polymorphism, the interpreter will take the decision during the runtime to decide which method to be invoked. So in dynamic method dispatch, so dynamic, which means that it is also runtime. So at the runtime, your JVM or interpreter will dynamically decide which method to be invoked, that is which method to be dispatched. So some places you may see something like dynamic method dispatch, or you can which is same as runtime polymorphism. So